Good day to each and everyone. Assalamualaikum warahmatullahi ta'ala barakatuh. This is Sir Hanif and um, continuing our discussion for our Physics 41. I mean Physics 132, no? So we have discussed the so-called the electric potential. Okay, so continuing our discussion for this topic, we will be having this electric resistance. Okay, so what do you mean by electric resistance? No, so last meeting we have discussed the how is electrons being generated, no, or how is electric current being generated. Okay, so it's because of movement or interaction of molecules inside the conductors. Okay, so right now, no, we will be discussing the phenomena in which that electric current oppose, no, or uh, have a counterpart in order for it to not totally go through the resistance or go through the conductors. Okay, so ibig sabihin nun, no, if we have a resistance, no, in a certain component or in certain conductor, we have a resistance. Okay, so it will depends on the um, materials that is being used, no, to have that conductor. Okay, so if you read this definition here, um, you would know the story and the historical development and analysis of electric resistance, no, or the electrons in relation to resistance. Okay, so we have here this connection. Now if you have this connection, you would know that the current that is going from this source papunta rito sa load na to would not totally have the maximum current, no, kasi nga we have a resistance to oppose that uh, movement or flowing of that current. So you have here the resistance, no, just read this one. Okay, so resistance is hindrance to the flow of charge. So yun. So it will oppose the flow of charge, no. Variable affecting electric resistance. So we have here the I think if you would read this definition here, you would know that most of the uh, variable that will affect the resistance is the how is the materials being generated, or how it's where that does that material came from. Okay, and another one is the temperature, no. um the temperature would also affect the value of resistance of a certain material. Okay, so for the higher temperature, you would notice that it has a very high resistance, and for that low temperature, it would reduce the resistance. No, if I'm not mistaken, that is the uh, relationship. Okay, so if you have this table, now we have here the material and the corresponding resistivity in ohm meter. Okay, so we have here silver up to hard rubber. If you would imagine, no, if you would notice, no, from that one, we have an increasing value of resistivity. Okay, okay, so most probably, no, in a industrial application, we have this copper, gold up to aluminum yung ginagamit. Okay? So, yan yung mga ginagamit na uh, material. Okay? So, we have here a mathematical nature of resistance. So, resistance is given by this formula. We have R is equals to rho L over A, where rho here is the resistivity of the material, and L here is the length of material, and A here is the cross-sectional area. So if you ask to find the value of resistance of a certain material, you must have the value of length and the area and the resistivity of that material in order for you to find the value of resistance. Okay? And for the resistance in terms of current and voltage, we have this Ohm's law. We have the voltage is equal to current and resistance. Okay? Or the change of voltage is equals to current and resistance. The if you ask to find the value of current in relation to the voltage and resistance, you just have to manipulate this equation in order to find that current. Okay, so we have I is equals to change of voltage over R. Okay, now as you can see here, we can notice that um, the relationship between the voltage and the current is inversely proportional, no? So if you have here as long as the value of, no, if you take this as a constant, no, we can say that the as the voltage increases, the current will decrease. Okay, but in here kasi, no, we also uh, vary the value of resistance. So, hindi natin nakita yung properly na kuan nila, relationship ng voltage and current. But if you take this constant, you can see that the voltage and current is, I think the voltage current is proportional pala, no? Proportional. So if you take this increasing, the current will also increase, okay? Due to this equation, no? Due to this equation. Okay, but all of these relations here, the value here can be derived using this formula. Okay, so we have here quantities, symbol, equations, and units. So we have the quantity of the current is this one, no? Current, power, resistance, and energy or potential difference. No, so in symbol we have change of V, I, P, R, and energy or change of potential energy. Then the equation is given by this one. Then standard metric unit is voltage, ampere, watt, ohm, and joule. And then other units, no, we can also use these other units in order to represent that one. But usually in a solving problem, we can just see these units here, no. So we have here electric power revisited, no. So I think these are all just uh, explainable naman. Okay? So, dito tayo sa circuit connection. Okay? Okay, so for that circuit connection, uh, we have here the single cell, no? If you are asked to represent the value of, or the represent the source voltage in the form of, of a single cell, you can just use this uh, symbol, no. If you are asked to represent the source battery, no, you can use this one. And for connecting wire we have this one, and then for resistors this one, then for switch is this one. Okay, switch that is open is this one, and switch closed that is this one. Okay, so we have here example, no. So drawing the circuit, no, we have here meron tayong battery, meron tayong LED. Okay, so if for us to have the schematic diagram of that one, so we have to represent this one by this symbol, then this resistance here is this one. Okay, so when you see this connection, type of connection, okay, uh, this is being represented here. Okay, so we have here the drawing of a circuit, no. We have here the source, we have here the resistances, no. So yun. Okay, so we have here two type of connection. So we have the series connection and the parallel connection. For the series connection, um, the node of the first, no, or the node of the the terminal of one resistance is connected to the other. Okay, so they are cascaded in series connection. And for parallel connection naman, their terminals are all connected. The first terminal is connected at this one node, and the second resistance is connected at this node. So in major subject, no, if you see the word node, no, the node is the point where the terminal of group of elements are connected. So this can be called as a node, and this is also can called as a node. Okay, so we have here exploring the series connection. Okay, so we have here. Okay, so I think it is readable naman, no? So we have here, so this is in for, okay, so we have here the series circuit, no? In order for you to find the equivalent of a series circuit, okay, you just have to add that one. So for example, if you have this connection of 6 ohm, no, their total resistance is equal to 24 ohm. So you just have to add that one. Okay, then for the current naman, no, for the current, it has equal value, no, for if you have a series connection, regardless of what is the value of that resistances, the current are all equal. Okay, so yun, please remember that one. Then for the voltage drop naman, no, for the series connection, its voltage drop is the summation of all. So if you, for example, if you have this connection, then the total voltage drop is the summation of all the summation of the voltage drop here, 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 and here. Okay, so you just have to add the voltage drop. Okay, in order to find the equivalent voltage of the battery. Okay, so we have here mathematical analysis of a series circuit. So this is very explainable naman, no, when you read that definitions and paragraphs. So dito tayo sa parallel circuit. So sa parallel circuit naman, we have here the connection. So if you have here as I have said, parallel connection is the connection of the circuit elements, okay, of their respective terminal. So we have here circuit element. Their first terminal is connected to this one, and then their second terminal is connected to this one. Okay? So we have here sa parallel circuit natin, the current is being distributed, no? Or the current is in order for you to find the total current, you just have to add the current here, and the current here. Okay? So we have I total is equals to I1, I2, and I3. Okay? Then its voltage is, okay, its voltage or its equivalent resistance muna, okay, is given by this equation. Okay, ito. Okay, so if you ask to find the value of equivalent resistance of the parallel connected resistance, you just have to use this equation. Okay, so we have R1 is this one. Let's say for example, R1 is this one, R2 is this one, R3 is this one. Then R equivalent is given by this equation. So we have 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so try to check this one, no? Itong 2 ohm, 2 ampere, 2 ohm na to. Paano naging ganito? So in order for you to check this one, you just have to use this equation. Okay? So we have here the voltage drop for parallel branches. So sa voltage drop naman, okay? Kung meron kang parallel connected na resistance, okay? Their voltage drop is parallel. Their voltage drop is equal. Okay? So we have here V of the battery, okay, is equal to the V1 here, the V2 here, and the V3 here. Okay? So equal. Kanina yung sa series connection natin, ang equal is yung current, no? If you noticed, no? Ang equal doon sa series connection natin is yung current. Dito naman ang equal is yung ating voltage. Okay? So take note of that. So we have here explainable naman yung lahat, no? Combination of the circuit is just the combination of parallel and series connection. So you just have to apply what we have already discussed, no, regarding on series and parallel connection. Okay? So these are the strategies in order for you to have the simplification on how to simplify the circuit, no? So please read also this one. So I think that's all. No, if you have any question regarding on this one, please ask it to me right before the exams. No. So that's all. Assalamu alaikum wa rahmatullahi